Hi everyone, today we're gonna explain the last lesson, the thermodynamic point of view of the unit number 1, the problem. This is a mainly theoretical unit that tried to explain the way that heat integration fits inside the thermodynamic of a process. Every process can be taken as a heat engine, where high-grade energy is transformed in low-grade energy, while a useful process, here prime matter transformed in product, takes place. For our heat integration subject, high-grade energy will be the heating utility, high temperature heat arriving to the system, and low-grade energy going out of the system will be the cooling utility, low temperature heat going out. But the concept is much more general than that. High-grade energy can involve work, shaft work, heat, electricity, etc. Low-grade energy in general is waste heat, heat at low temperature, just at the temperature enough to go to the atmosphere. But take into account that even if low-grade energy is not expensive, for us, is technically as important as high-grade energy. If low-grade energy is not taken out of the system, the process will stop. Our plants normally take prime matters and through some transformation, reaction, separation, and so on, we arrive to some products. This is the normal way. But imagine a more general concept. For example, the human body works on high-grade energy, that is food, and leaves some low-grade energy, that is waste heat, through our skin and produce some transformation, speaking, thinking, moving, and so on. The concept of utilities in this context is serve to drive the generated entropy out of the system for the system to continue alive, or it can be also understood as the utility maintain internal gradient temperature or pressure alive in order that the driving force can perform the transformations. Then for us this is important. We want to maintain gradients alive for the process to work, and in order to do that one must add heat at the hot end, high-grade energy, high-temperature energy, continuously, and withdraw heat at the cold end, the low-grade energy, low temperature, also continuously. If you don't do that, the gradient vanishes or dies and goes to equilibrium state. This is the dead state or the maximum entropy state. In simpler words, if you are heating a process at one end and cooling the process at the other end and stop heating it, the temperature goes down and down till the environmental one and the process stops or dies. The gradient has disappeared and is the gradient that maintains the process alive. And it's here when the heat integration enters this theoretical framework, because heat flows down spontaneously with temperature. It falls down with temperature. The heat withdrawn, taken out to cool the stream, can be then added at a lower temperature to heat another stream. and therefore can be used several times along the whole range between the highest heating temperature and the lowest cooling temperature. It's like reusing this heat. This is heat integration. And this is the end of this theoretical lesson.